An executive asks the AI, "What was our net revenue last quarter?" Unconstrained, it creates 3 parallel branches of logic, generating unique SQL queries based on different guesses. The math diverges, returning 3 conflicting totals for the exact same prompt. This is the analytics inferno. 3 different stakeholders walking to a meeting, each holding an official AI-certified number that contradicts everyone else in the room. Discrepancies used to be caught during multi-week sprints. Today, conversational BI allows 50 people to generate 50 conflicting charts in less than 2 minutes. High-speed compute engines can run unverified SQL in milliseconds, but that speed often results in wrong answers at a massive scale. Solving this misalignment involves a move toward a decoupled data stack, where a code-first semantic layer governs the data before the AI ever presents it. In an enterprise environment, this failure is a new version of garbage in, garbage out. We can think of it as garbage in, hallucination out. When an LLM writes clean, executable SQL, it projects a false sense of authority. Non-technical users see the code and assume the underlying business logic must be correct, but speed and syntax are not substitutes for accuracy. If the AI guesses at table relationships, the result is an instant hallucination. Fixing this requires a look back at where legacy architectures succeeded in governance, even while they struggled with speed. Moving fast is only valuable if it doesn't accelerate organizational friction and lead to misaligned decisions. Standard enterprise architecture follows a vertical flow. A massive data warehouse feeds a proprietary BI server, which renders a dashboard. This creates a double-dip cost structure, paying for compute, then a second seat tax just to view the results. These high fixed costs are often charged every month, regardless of whether a stakeholder actually opens a report. A more efficient approach replaces these idle warehouse clusters with localized high-speed compute engines, a framework often called the Duck Stack. Engines like DuckDB execute queries in milliseconds directly against open formats like Parquet. This allows organizations to process data right out of an open data lake, bypassing the traditional, expensive warehouse block. Decoupling the compute engine allows the data budget to shift. Instead of paying for bloated software licenses, you pay for the actual processing of your data. Speed and cost efficiency are solved, but this raw performance brings us back to the problem of semantic chaos. Here is the architectural risk. If an LLM agent connects directly to a high-speed compute node, the raw database tables are completely exposed to the AI's interpretation. This creates semantic divergence. Every department has a different definition for core metrics like revenue or churn, yet the AI sees them only as generic columns in a table. When 3 different departments ask for revenue, the AI has no context to determine which version of the truth they actually need. Without guidance, the LLM guesses, firing 3 separate queries and making arbitrary decisions on which tables to join. Hard-coding formulas into the AI's prompt to fix this is a mistake. It repeats the legacy error of locking business logic inside individual dashboard canvases. Without a structural intervention, dropping conversational AI onto raw data effectively hands a flamethrower to every stakeholder. To prevent hallucinations, the business logic must be moved out of the prompt and into the architecture itself. We solve this by inserting a semantic layer between the compute engine and the AI as a code-first vault for every metric. The AI translates natural language into queries against these pre-tested models, returning one unified output instead of scattered SQL. Centralizing logic in version-controlled code ensures net revenue is mathematically consistent across every department. In sectors like healthcare or finance, this level of determinism is a regulatory requirement. Probabilistic LLM prompts cannot reliably manage security filters or row-level access. In these environments, security policies must be enforced in code before any data is presented. The semantic layer is the bridge that allows for instant AI queries while maintaining absolute enterprise governance. It is tempting to think that conversational AI makes traditional data visualization obsolete, but stakeholders often experience prompt fatigue. They don't want to actively engineer a text query every morning just to check the basic health of their department. Analytics requires a balance between active exploratory intelligence, asking ad hoc questions, and passive governed intelligence, which involves monitoring daily trends. Text-based chat responses are poor at communicating spatial context. They lack the immediate visual clarity of historical trend lines and seasonality. The modern architecture splits the semantic layer output into 2 tracks. One feeds an AI chat for active questions, while the other feeds a lightweight visual data app for passive monitoring. These visual surfaces render instantly on the Duck stack, allowing for high-performance monitoring without the high-per-seat licensing costs of legacy BI tools. The stack doesn't kill visual BI, it simply decouples the presentation from the heavy compute engine. If AI can write SQL and generate answers in seconds, it naturally creates anxiety for data teams. The human role has not disappeared, it has migrated backstage. Developers are moving away from manual dashboard layouts and toward becoming context architects. They now focus on building model context protocol servers and semantic schemas. Their job is to ensure the AI has a robust foundation of business logic. Instead of moving boxes on a canvas, the developer curates the socio-technical information that allows an AI engine to understand how the business actually operates. An AI agent is only as smart as the business logic curriculum built by the human engineers behind the curtain. Obsessing over query speed or SQL syntax is a distraction if the resulting data doesn't lead to a concrete business action. This architectural shift allows teams to manage data as a finished product. Metrics are defined as governed decision tools, built specifically to provide utility for stakeholders, rather than just existing as rows in a warehouse. By decoupling compute and locking down logic in a semantic firewall, organizations can finally anchor their AI to an unshakable source of truth.